Hello, statistics. Welcome back. Here's chapter 5 homework. So as you see, there's only 15 questions, but there's still 30 points. So that means that each question is worth 2 points each. So make sure that you notice that towards that final total. So the first question here is asking about determine whether the value is discrete random variable, a continuous random variable, or not a random variable. So what's going to happen is a discrete random variable is going to be something that is countable. For example, the number of trees in a yard. I can count the number of trees, the number of students in a class. Continuous random variables tend more to be something about weight. So if you're weighing your apples, you can have 1.267 pounds of apples, or you're weighing, you're buying some hamburger meat. Or not a random variable, is just the variable's not random. So is the time to take to fly from city A to city B? Well, that's going to be continuous because it's not going to just be 6 hours. It could be 6 hours, 35 minutes, and 26 seconds. So there's pieces in between there. The time it takes for a light bulb to burn out, so that's also going to be continuous because that could also be 27 hours, 36 minutes, 21 seconds. Is the gender of a college student? Well, that's not a random variable because it's male or female. The amount of rain in city B during April, well, that's also a continuous random variable. The amount of snowfall in December in city A, also continuous. Number of points scored during a basketball game, that is discrete. You cannot score 121.3. It's 121, 122. So that's the difference between not being a random variable, continuous, and also discrete. So 5 males with a particular genetic disorder have 1 child each. Random variable X is the number of children among the 5 who inherited genetic disorder. Determine whether the table described as a probability distribution. If it does, find the mean and the standard deviation. And so here, what we're going to do is, so we have the number and the probability. If you're in Excel, you can use something called a sum product, or you could go ahead and multiply 0 times the probability, add it to 1 times the probability, add it to 2 times the probability, plus 3 times the probability, plus 4 times the probability, plus 5 times the probability, and that would get you your result. So instead of doing all of those calculations, one thing that you can do is use StatsCh5. So I did embed a video into the announcement that includes this video that will show you step by step how to go into StatsCh5 and use it. So you're going to use this, open in StatsCh5, and then you're going to go into Stat, and then you're going to go into Calculators and Custom. The values are in X, the weights are in P of X, and this part of it, we don't need anything. So we're going to compute, and we're going to see the mean is 3.6501. So they wanted it rounded to 1 decimal. So 1 decimal, this right to the right of that 6, there's going to be a 5, so that 6 becomes a 7, 3.7. Standard deviation rounded to 1 decimal place. So the first decimal is a 9, but to the right of it is a 9, so that's going to become 1.0. So the next question here, the accompanying table describes the results from 8 offspring peas. Random variable X represents the number of offspring peas with green pods, complete pods A through D. So we have to click on here to see what we're looking at. Probability of getting exactly 7 peas with green pods. Number of peas with green pods, exactly 7. That's going to be that 0.301. That's my answer. Of getting 7 or more. So that means 7 or 8 according to this. So I have to add 0.301 plus 0.099. That's going to be 0.4000. So 0.4 would be my answer. Which probability is relevant to determining whether 7 is an unusually high number? So that's going to be part B because that's 7 or more. Is 7 an unusually high number? No, because remember 0.05 is going to make it unusually high. If under a given assumption, probability of a particularly observed event is extremely small, we conclude that the assumption is probably not correct. This represents the rare event rule. A Gallup poll of 1,236 adults show that 12% of respondents believed it's bad luck to walk under a ladder. Consider the probability that among 30 randomly selected people from the 1,236 who were polled, there are at least 2 who have that belief. Given that the subjects surveyed were selected without replacement, the events are independent. Can the probability be found by using a binomial probability formula? Yeah, it can. Although selections are not independent, they can be treated as being independent by applying the 5% guideline. Because remember, it's 2 over that 1,236. Determine whether the following experiment represents a binomial experiment and explain your reason. 4 cards are selected from a standard 52-card deck without replacement. Number of hots selected is recorded. No, it's not, because the trials or experiment are not independent and the probability of success differs from trial to trial. Assume the procedure yields a binomial distribution with n equals 4 trials and a probability of success p equals 0.9. Use a binomial probability table to find the probability that the number of successes x is exactly 3. So click on the icon to view the table. So here's my table. So what you want to do here is n equals 4. I'm going to come down to n equals 4. X is exactly 3. So I'm going to come to 3. And my p equals 0.9. So I need to go 4, 3, and come all the way over to 0.9. And there's my 0.292. So that's going to be my answer. So you have to use the n, the x, and the p in order to find the correct answer. So the next question doesn't give you a table. Assumes the procedure yields a binomial distribution with trial repeated n times. Use the binomial probability formula to find the probability of x successes given the probability of p of success on a single trial. So what I'm going to do is I am going to show you a calculator. I'll also embed this into this announcement. Probability of success, that's going to be my p. I'm going to put 0.45. The number of trials, that's going to be 7. So n is number. And then x is going to be 3. And then there's going to be a calculate button. So you're going to click on that calculate button, and it wants it rounded to 3 decimal places. So binomial probability, p of x equals 3, 0.2918. 3 decimal places, the one, look to the right, it's a 5 or above, 0.292. There's my solution. Note you could also use this calculator for the previous example. So in the binomial probability formula, the variable x represents the number of successes, because remember, n is the number of trials. In a clinical trial of cholesterol drug, 294 subjects were given a placebo. 8% of them developed headaches. For such a randomly selected group of 294 subjects given a placebo, identify the values of n, p, q, which would be used for finding the mean and standard deviation. So the value n, the number of people tested, is 294. P, the number that get a headache, 0.08. Remember, probability is 8%. Percentage sign leaves, it moves to the left 2 places. Get it? If someone leaves, they left you. So it moves left 2 places. And 100% is perfect, so that's why it's 2. So 8, 1, 2. The value of Q. Q is always 1 minus P. We always want to add up to 1 or 100% in probability. And so 1 minus 0.08 is my 0.92. This one's going to ask you to do a little bit more work. Assume the procedure yields a binomial distribution with n trials and probability of success for one trial is p. Given the values of n and p to find the mean and the standard deviation, also use the range rule of thumb to find the minimum usual value and the maximum usual value. So if you forget the formula on this one, what you can do, question help, view an example. As soon as it comes up, it's going to tell you the mean is n times p. The standard deviation is the square root of n times p times q. So we're going to pull up the data in Excel. So we're going to type it in. N equals 1,546. P equals 1/2. To convert a fraction into a decimal, divide the numerator divided by the denominator. 1 divided by 2 is 0.5. This one's pretty straightforward, but your example might be different. Q is 1 minus P. So you can just do the formula 1 minus P, or 1 minus 0.5 or 0.5. The mean, you're going to multiply 1,546 times 0.5 and get 773. So that's my solution for the mean. That mu looks like it's a Greek M, so that stands for mean. Standard deviation, the square root. So you can either use your square root button or on your calculator after you multiply n times p times q, or you can use equals SQRT, open parentheses, in Excel in order to get the square root. So I get 19.6596, but they want 1 decimal place, so that's going to round to 19.7, because to the right of that 6 is a 5, so that 6 becomes a 7. I can also either do it in on my calculator or I can do it in Excel. Note if you're doing it in a calculator, order of operations, you have to multiply 2 times the standard deviation. So we're doing the mean minus 2 times the standard deviation. I have to do that multiplication first on my calculator. When I do my formula, 733.6, and when I add 2 times the 19.7 to the 773, I get 812.4. So that's my solution for that part. So here's another one that's going to be very similar calculation-wise. Another one very similar calculation-wise. And here, the main goal in statistics is to interpret and understand meaning of statistical values. The range rule of thumb can be very helpful in understanding the meaning of the mean and the standard deviation. And then refer to the accompanying technology display. Probabilities were obtained by entering values n equals 5, p equals 0.744, and a clinical test of a drug. 74.4% of subjects treated with 10 milligrams of the drug experienced headaches. In each case, assume 5 subjects are randomly selected and treated with 10 milligrams of the drug. Find the probability at least 4 of the subjects experienced headaches. Is it unusual to have a headache? So for this one, I want to definitely make sure I open up my data. And so you are going to want to click on this and then open in Excel. When it opens in Excel, you want to know the probability that at least 4. So that's 4 or 5. So you can just select both and look at the sum down here, that's 6202, or you can use your calculator, or you can use a formula to add the two of them together. 0.6202. Is it unusual? No, because the probability that fewer than 4 subjects will experience a headache is not unlikely. So that is the Chapter 5 homework. I hope it was helpful, and I hope you guys have a great day.